Welcome, everyone. My name is Jennifer Fritchie, and we're excited to host the March Nuggets of Tech and Telecom for Georgetown. We're really excited about our guest speaker today, Scott Wallsten. Scott, welcome. For our audience, Scott, keep me honest here because it's quite an impressive title, but is president of the Technology Policy and Institute, as well as a senior scholar at the Georgetown Center of Business and Public Policy. Also, Scott is quite a tenured expert of federal subsidy programs for the broadband industry. So welcome, Scott.
Thank you for having me.
Thanks for coming. So I'm going to start just by addressing clearly the elephant in the room. This is a really interesting time and timely time for this call because the broadband gods are raining down on the subsidy world. The Congress has authorized over $42 billion to be spent on the digital divide with the recent passing of the infrastructure bill. And as an analyst, I'd seen this before. Not clearly the amount of subsidy, but we've seen billions of dollars thrown to the broadband industry before. And I'm just curious as to your thoughts as to why this time is seen to be different.
Well, we don't know yet that this time will be different. We hope it will be. And of course, that $42 billion is just the infrastructure part. There's another 14 or so billion for the Affordable Connectivity Program too. And so we have spent billions of dollars, tens of billions of dollars, probably in real dollars, close to $100 billion subsidizing rural broadband. And that's because of the Universal Service Program, which spends, in total, $8 to $10 billion a year, probably 6 or 7 billion of that on rural programs. So yeah, we do have a long history of that. And hopefully this, and of course there was the BTOP program back in 2009, and the subsidies were not given out efficiently, not very well. Report after report has shown them to be problems. The FCC has started to improve with reverse auctions. It's been working really hard on that. This time, the money's going to the states with oversight by NTIA, and what exactly that oversight means, we don't quite know yet. So there are probably going to be a lot of different approaches.
And clearly this is COVID showed us so much, but clearly the need for broadband really is a lifeline in many cases if we rewind the clock 2 years as to people continuing on normal work lives. Do you think that is, and I know we're going to have you go through your project, but do you think that has really increased the urgency and need to get this right?
Yeah, the demand for broadband should have gone up during this time. Students needed it for school. People were finally able to do telehealth. People are teleworking. I'm here at home in my study. And although, of course, I had broadband, I'm one of the fortunate. And so yeah, there's more demand for it. Whether this is the right amount of money or not, I don't know. The bigger problem has always been low income connectivity rather than rural connectivity, although I don't want to dismiss the rural problem either. It is real. And so the Affordable Connectivity Program, I think, hopefully will make a big difference. I think the FCC is doing a good job with it. It is more or less like a voucher program, which is what we would, what we would want. And it can, it effectively makes, along with the Lifeline program, effectively makes broadband free for people who are eligible. So hopefully that at least will make a big difference.
And how I want to go through, you've developed a very interesting database that I'm wondering if you can showcase here, because and I want you to discuss and connect the dots as to how this will be relevant to the states receiving these funds for this broadband stimulus.
Well, so fortunately, I have a PowerPoint that will talk about some of these things. But each state is going to need to build a broadband plan. And also decide how to implement how to distribute their funds. So each one is going to need lots of data to make good decisions. And so, hopefully this project will help bring it to them. So we have, in addition to the national map, we have state maps. And so people can look specifically at their individual states, which we hope will help.
Terrific. Does it make sense to pull up that PowerPoint and kind of, I'm sure I'll stimulate more questions from that.
Sure. If you want me to get started on it, I will do that. Okay. All right. So I assume you can see the screen.
Yes.
Right. So there's a QR code. You can scan it and go right to the map, or maybe we'll be hacking your phones with the QR code. You can't tell until you try it. So there are actually two sites. One is tpibroadband.com has the map. TPIreports.com is a site where we have E-rate intelligence reports if people are interested in that. Let's see here. It's not clicking forward. I think I have to go here. Okay. So like you said, there's, it's just raining money, or it's about to. And so we need to do something about it. And as we've talked about, the existing high cost fund has not done a good job. GAO and others have been telling the FCC for years that they have to that they need to fix it. We know it works, which is competitive bidding, and even RDOF, the Rural Development Opportunity Fund, which has gotten a really bad rap partly because of the outcome that so much money went to one firm in particular that may not be able to meet its obligations. We'll find out. And people who don't like auctions and competitive bidding have used that as a way to make competitive bidding, to make auctions sound like make auctions a bad word, which is why they don't appear in the legislation or so far any of the rules. But the problems, if RDOF did have problems, they were about eligibility requirements and identifying eligible areas. That would have been a problem for any mechanism. It had nothing to do with the auction. And that's very important. And those are things that may have been big errors, not sure. But the RDOF complaints are unrelated to it being an auction. There's lots of evidence that reverse auctions are the most efficient way. Okay, so let's talk about the map. So this is this is actually a snapshot of the broadband map, just showing availability. But the thing I wanted to highlight there is this little button down at the bottom, little coffee cup. We have no direct funding for this map. We've built it all on our own resources, and it's extremely expensive to build and maintain. It's very complicated. I think it can do more than any other maps. You'll see. But so if you want to give us $5 or 50,000, you can do it through there. So tip your waiter. Okay, so let me go right to the actual map itself. There's my email, so you all can see that. Hold on. Okay. So when you go to the map, this is what you'll see, and we have lots of databases in there. So you can see availability for fixed wireless, mobile coverage, adoption, speed test from Ookla, and then this speed threshold data from Microsoft, emergency broadband benefit, the rural development, the RDOF, and keeping up with what NTIA has proposed. For each of those, you can choose almost any geographic area, and exactly what appears in this dropdown will depend on what you've chosen as your data source. And then from there, you can refine it further by saying what it is you want to see. And in this case, I have the map showing the share of households that will have access to 100 megabits per second up, down, and 20 megabits per second up, 120. And so you can change that. It'll change the map on the fly. It's a little bit slow sometimes. You might have to reload it. That's in part because of our resource constraints. It's all runs in the cloud, and so we have to be careful how much it's spending. And it's one of the things about our map that's different than others also is that it calculates everything in real time, so we can update the data, which we all the time. This is not a picture that just gets displayed. And we can do things. You can compare counties and so on with these time series, or it'll draw on the time series whatever variable it is you're looking at. Let's just go through a couple more of these. And by the way, this is like cooking show magic. I've preloaded some of these so that they're not going to crarash.
You got all this information. You built all this from the FCC data points, but
so it's more than the FCC. So this started because we do lots and lots of empirical work on broadband.
Yeah.
And each time it involves merging different data sets, which can be complicated because the geographic areas aren't the same or whatever. So we wanted it all to be in one place. So, that we wouldn't have to waste time doing it each time. And then hopefully other people could use it too. So right now it has data from the FCC, the census, UCLA, Microsoft, and all of the universal service data, including all of the E-rate data. This is all public information, and we built it so that we can add any data, almost any data set we want. So we don't see it as a competitor to many of the existing maps. Like, for example, the FCC's new fabric that it's working on. We can't wait for that to come out because we want to incorporate it into this map. So this is really, it's a platform, and it allows for analysis, which we'll talk about in a second. So this one, this is a map showing adoption, this overall broadband adoption at the congressional district level. So we have to add the names of the states here, but you can see how it's changed over time. More interesting than overall adoption, you can see low income adoption. This is the share of households with less than $20,000 who have broadband. This is from the ACS, American Community Survey. And again, you can see all of the these are all of the different types of all the different adoption variables that you could look at. And you can change on the map, you can change the time that you're looking at, and on the right, you see the data, the time series of the data.
Okay.
Here, it's didn't finish filling out. This one is just mobile coverage. It's showing census block groups of mobile coverage. One thing people like to do when they come to the map, which is kind of a mistake, is try to see census blocks from a national level. You can't do that. There are 11 million census blocks.
Wow.
And so any map that will let you see census blocks across the whole country, they have to fake it. This is not a criticism. You just have to, because you can't see census blocks. So instead of showing blocks, it'll show census tracts or something. And then as you zoom in, then you can see the actual blocks. That's also what we've done.
11 million census blocks nationwide. What's the average number of miles a census block covers? Or is that easy to answer?
Well, it's usually it's hard to answer this. The census, I mean, it's defined by the census, but it usually, I believe, has to do with, it's a combination of population and area.
Okay.
And it's one of the problems with the FCC's availability data. Actually, it's part of the root of the issue people are worried about. And it's not a criticism of the FCC, of course. They know that issue, but a census block is considered to be covered or have service if an ISP serves even one customer in that block. So that causes it to overstate availability.
Okay.
When you're trying to look at trends and lots of analyses, it's fine. If you're trying to identify specific, very specific areas that don't have service, then it becomes a problem, and that's what the FCC is trying to solve. There's RDOF money, and here's, if you scroll down, we've built in some, in addition to the time series, various kinds of analysis. So we have a small regression. It's just a one variable regression where you can, one variable on one variable, where you can select any variable and regress it on any of the other variables. We're working on a multivariate regression tool. And so this is the amount of money assigned to RDOF by RDOF and adoption. And of course, it's mostly clustered here because just overall adoption is pretty high. But you can see, as you'd expect, there's more money going where there's where adoption is lower.
Yes.
You can see this, there's something similar in this was the emergency broadband benefit, which became the ACP. And you could look at that correlated with, what am I looking at here? Just subscribers. So it states the higher share of households enrolled where subscription was lower. So that's kind of what we hope happened. Now the focus of the map really is analytics. It's always up to date. We can incorporate any data, and there's a lot more than we can put on there's a lot more in the back end than you can see on the front end. And I'll talk about some of that here. So what can we do with it? Because a map isn't really useful just as pictures. So for example, I showed you that it can calculate the share of households that have access to broadband at different speeds. Yeah. So in this case, I've kind of flipped the map. So this shows the share of households who are eligible for subsidies who do not meet the threshold when the definition at different definitions. So at 25.3, you can see the map is very light. There's not a whole lot of areas that need subsidies, although some, of course, still do. And as the speed threshold increases, more and more areas become eligible. But what you can also see then is what it means for who will get subsidies. So on the second row, this is who would get subsidies, but also has at least 25.3, but up to 120. So if the definition is 120, all of those people in that middle box are in areas that would be eligible for subsidies, but they already have broadband that's that good and sufficient, and same for that rest. And even if you were to set the definition at a gigabit down and 100 megabits per second up, you would have all these people here in the bottom right who have at least already 120 who would be in areas eligible for subsidies. And then you can turn that into a graph. And the blue is the number of households in areas eligible for subsidies under different definitions. The orange is households that already have service, but don't quite meet the definition. And so you can see the higher you set the definition, the more households you have to cover, the more expensive it'll be to cover them, and the more of them already have broadband of some sort. So that's why it makes a difference. And it's up to policymakers to decide what that definition should be, but it has consequences. And here, this is not meant to argue one thing or another. It's to show one of the ways that the map can be used, because we don't have to calculate. The map automatically calculates how many people are eligible or how many people are covered by different definitions. Now, one of the benefits of lots of data sets is that you can combine them. Any given data set has error in it. Even the FCC's new data set that's supposed to show the connectivity of every structure in the US, it's going to have error. It's just the way data are. And you can learn more by combining multiple data sets. So, in this case, we've created what we're calling a broadband connectivity index. And we can tweak it depending on what it is you want to look at. Like we could have one focused mostly on low income, for example, but this is overall connectivity. So this takes into account the share of households that have access to 120, to 25.3, the actual download speeds as measured by Ookla, the maximum available speed, and then the share of households with broadband. So we do principal component analysis and put into our sophisticated algorithm, which I represented here as a speak and spell, and to create this index that allows comparison, more rigorous comparisons of any geographic area. In this case, we did counties. So this shows the results. And so if I click on any county here, the index here is 0.94, but you can see it has 80% with broadband, very good availability, and well, any measure that you want. Wherever. Let's go to somewhere in West Virginia here. There we go. Lower numbers on the index are worse. So you can see share with broadband 70%. That's not terrible, but almost everybody has access to 25.3 and not more than that. Is that sufficient? That's a different question. But this allows you to compare. So a state, for example, could take this and say, okay, here we've got we can identify the counties that need special attention, and we can focus on those first. And it might just be to gather more data, but this is a way to begin to figure out what they need. Let's see if I can get it to move again.
Can I ask a question? Like if I've had some questions from wireless companies who have asked me, do you know anything if I can get access to some of these dollars? If a wireless company, would your database be able to help them?
Yes, absolutely. We have mobile coverage in there, but that's probably not exactly what they want. Anybody who's who hopes to get money is going to want to know where there is service and where there isn't service, who's connected and who isn't.
For fixed wireless access would be you know,
right, exactly. And we can do mobile too. I just don't know exactly. So it can.
Okay.
And recognizing that it's still doing it using public data, right? So with the caveats that the existing data sets have problems, and that's one of the reasons why we need to look at multiple places. Oh, by the way, so let me explain the manatee.
Yeah.
We're doing some work with Mark Jameson and Florida. That's not meant to represent Mark Jameson, but it's Florida, the state marine mammal. So these are just some things we did for Florida that I want to show other way can add additional data to yield more insight. So in this case, they want to know differences by urban and rural. So we use this urban rural classification scheme to divide their counties, and you can see how speeds as measured by Ookla, sorry, it should say the source is Ookla on there somewhere. It doesn't, it should, the underlying data. And so you can see how it differs in urban areas to rural areas. Here you can see the the counties themselves. This should scroll, but yeah, so how connectivity has changed over time among low-income people. And this is, we're using here data wrapper to visualize the output from the map, because it's a very nice way of seeing the data. Let's see what's coming next. There we go. Now, when we can also do much, don't worry about what the numbers are, but we can do much deeper analysis. So, suppose you want to learn more about the digital divide. We can say, what's correlated with who has access to 120 service or to 5G, and then who has a broadband subscription. And, in this case, it's most of the results are what you'd expect. Higher population density is correlated with better access and better access to 5G, higher incomes also. The share of the Black population is actually associated in this case with better availability, but lower adoption, which is interesting. But don't take that as a research conclusion, because these are not well specified equations. This is really for to provide it was quick to show an example of the kinds of things that we can do. But that did surprise me. I need to look at that more. Another thing you can do with this is help identify errors. So if you look in Florida, the share of households living in census blocks, this one uses block level, with access to different speeds, you see that in 2019, the share that had access to 100 appeared to drop, which doesn't make any sense. And so Nathaniel Lovin, who is our computer genius who programs everything, dug into it, and you can go into the raw data, the FCC, and there's a fixed wireless company that stopped reporting to the FCC, and they said they had 100 coverage, but then they just stopped reporting. So it appeared that the share covered went down, but it's not real. So that would be an example of where the state would want to go back and look and find out what really is the coverage in those areas. And then states have unique definitions and designations. In Florida, they have these counties designated as rural areas of opportunity, and different definitions of served, underserved, and unserved. And so we can slice the counties that way to see what the share of people are that are served under these different designations. Oops. So that's just a little piece of the map. We also have these things, I guess I won't go into it, TPIreports.com, these E-rate intelligence reports where we take the data from all of the data from USAC and put them into nice little reports. Maybe I can show you actually. Yeah.
Scott, who's like the audience?
Anyway,
who's like the main audience for this? Carriers, obviously, maybe E-rate providers.
Yeah, I'm going to stop sharing my screen. Yeah, so it's a good question, because at first the audience was us, and so one thing we still want to do is have data, raw data downloadable, automatically merged and then downloaded for people. But the audience is it's policymakers, congressional staffers, who want to see different different cuts of the data. Firms can use it to help identify areas that they want to invest in. You can look for areas on the edges of network. Of course, the providers have much more detailed maps themselves. I think it's particularly useful for states who have to develop broadband plans and need sort of this overall data. They don't need to spend millions of dollars for somebody to take the FCC's data already. And yeah, so that's it. And I should have mentioned at the beginning, sorry, that Sarah O. Lamb and Nathaniel Levin are key players in this, and they're more the brains than I am. So I neglected to say that at the beginning. I'm very sorry about that. They deserve immense credit. It's like I said, we have no direct funding for it, so this really is a lot of work with for not being funded.
Well, mapping has become such an issue, so to have this tool is incredibly helpful. I'm curious because in my world, in like finance and investment banking, some of the infrastructure funds I talked to, and I'm curious as to your view, would say that fiber in rural America doesn't really work unless it's a multi-technical use for it. So think fiber to the home, E-rate, fiber to the tower. What am I forgetting? Small cells, maybe not real applicable in rural America. But do you agree with that?
Yeah, I think the push for fiber is way overblown. There's simply just it in many places it is not justified. The claim that we need symmetric service makes no sense. And since we're on Zoom, I like to show people an example of this because you can see it right away. If you're on Zoom and in the bottom left you have the stop video thing. I'm not sure if you're a participant in the webinar, but if you click on the little arrow, you can get to video settings and then go to statistics. And then you can see that, for example, I am using for this call 1 megabit per second up and 800 kilobits per second down. So, to say that you need a gigabit for video, for interactive video it's just wrong. It's just silly. I could be running 700 of these video chats on a on a gigabit connection, but that's not to say that it's always easy, because there are lots of other features of the transmission. And so for real time, things like jitter and latency and all matter a lot. And fiber is good with those. No doubt about it. But fiber is more expensive than other solutions, and it's often not going to be the right answer.
And so is your view that wireless really could play a role? I mean, I noticed one of the questions on the chat was the question I asked earlier, data on mobile broadband speed availability. Oh,
right. Yes, we do have that. And again, though, at the moment, it's the FCC's data. So whatever errors there are in the data, obviously exist here too. But it's still, it's still pretty good. It's still by block. But actually, I forgot your question.
Sorry, do you have data on mobile broadband speed availability?
Yeah. Oh, right. And whether it'll be appropriate. Yeah. I think wireless now will be is poised to be a competitor in ways that it wasn't before. I think it has, to fix to wireline broadband. I think it always has on the edges, because it's a substitute for lots of people, perfect substitute for lots of people, very imperfect for some. You couldn't stream to your giant TV, for example. Sure. But now, I mean, the 5G hotspots, the 5G hotspot from my phone now is the best connection in my house. It's really? Much better than my wired connection. In a rural area. And there's Starlink. Oh, no. I mean.
Oh, Scott, we may have lost you. All right.
Yeah, so I mean, here where I Verizon. Oh, am I back?
You're a little garbled. Can you hear me? Scott? Scott, now I think you're back. Whoop.
Okay, I'm going to turn off my video.
Sure, no problem. It's ironic we're talking about this right now.
I know, and I was going to say it's actually a good example, because a speed test right now shows that I'm still getting close to 100 megabits per second. So it's obviously something that has nothing to do with bandwidth. But also I want to switch when this happens often, I switch to my 5G hotspot, which works much better. So I think wireless is going to be, and we don't really know yet what role Starlink will play. SpaceX, low Earth orbit satellites. We'll see. It's an exciting time for that, I think.
Well, that's great. It's a perfectly timed webinar, because so much of, all the carriers are now, each of them, AT&T, Verizon, T-Mobile, are breaking out fixed wireless subscribers as an important part of their customer growth. And the skeptic in me would say it's just saying, look over here, because the growth in traditional wireless isn't what it once was. But based on what you just said, it actually makes me think there's more meat on the bone as to what's to come from wireless market share gains.
Yeah, we'll see. You're the cynic, and you might be right. It certainly could turn out that way.
Right.
But I've been impressed with the service so far. Not that an N of 1 means anything at all.
In the interest of time, I know we got to wrap up, but could you give us, if people are curious as to how to get in touch with you? I think you had a slide up there earlier. Maybe just put it, or tell us, are you LinkedIn, Twitter? What's the best way to keep in touch with you?
So where is my share screen? Okay, it's not in presentation mode. But you can see the PowerPoint window. So there's my email. You can get in touch with me that way. I'm on Twitter, just Scott Wallsten, all one word. It's pretty easy to find me. Just Google me. Any questions you want, and then I may also, depending on your questions, direct you to Sarah and Nathaniel, both of whom know much more than I do. But yeah, get in touch with us. We're happy to. If you find new data sets that are public, we would like to incorporate them. Ideas for features. We have a huge list of features we want to implement. So ideas for features, along with money to implement them. Would be great.
Terrific. Well, Scott, thank you so much for the time. It was again very timely with all the talk about mapping and broadband infrastructure money coming. So to have tools like this, I know from where I sit, are going to be invaluable to the customers that are recipients of these dollars. So thank you so much for the time.
Thanks for having me, and I appreciate everyone humoring me while I go through all these things the map can do.
No worries. And we hope you all will join us. We're in no date set, but it's for late April, a Wednesday in late April, for our April Telecom Nugget and Tech session. So thank you everyone for taking the time today, and have a good remainder of the week. Thanks again, Scott.
Thank you.